Good morning to all. I am Dr. Thayalan from Radiologic Physics Foundation. Last class, we have been discussing about ionization chamber. Today, we are going to talk about Geiger-Muller counter or simply GM counter. Why we need GM counter? We all know that we have been using radioisotope for human health care. Therefore, there is a need to detect the radioactivity as well as to limit the radioactivity to the human system. So therefore, we need a very sensitive detector system to detect such radioactive material. GM counter is one of the suitable detector which is more sensitive for above task. It is basically ionization chamber, came in 1928. This counter is made up of a cylindrical cathode with a fine wire anode along its axis. You can see here, this is the cylindrical cathode, this is the fine wire serves as the anode. It is actually given a suitable potential and the signal is measured across the resistor. This is actually the window through which radiation enters. So the cathode serves as the outer electrode. It is made up of metal or metallic film sprayed on inside of a glass or plastic tube. So inside the cathode cylinder, you can have metal or metallic film sprayed inside of a glass or plastic tube. So how much voltage to be applied? A high voltage of 500 to 1500 is applied across the chamber. What is the inside the medium? The medium is mixture of gas. So mixture of gas is used as a medium to get maximum amplification effect. What is the specific mixture? Argon plus quenching gases are kept in the cylinder and the cylinder is sealed. Some counters are provided with a thin window at the tube end. Probably here, you can see here. Such meters are provided with pancake type detectors. This part is called pancake type detectors. Such meters are provided with pancake type detectors. You can also have removable covers here in this point. You can have the removable covers at the entrance so that you can distinguish between penetrating and non-penetrating radiation. That means you can detect the radiation with the cover. Same time you can remove the cover and detect the radiation. Then you can find out which radiation is penetrating or non-penetrating like that. What are the various type of GM counter? There are two types. One is called N window. The other one is windowless, almost thin. N window having a thin window of 0.1 mm aluminum or stainless steel. It is useful to detect high energy beta and gamma rays. So this is used mainly for penetrating radiation. Windowless or actually very thin window, 0.01 millimeter thick mica, useful for alpha low energy beta particle, that is less penetrating radiation. This fragile window is protected by a wire screen. You can able to appreciate the wire screen will be somewhere here in this point. Wire screen will be there so that it get not be physically injured or damaged by any mechanical items. Let us see what is the type of quenching gas used and what is the advantages and disadvantages. The quenching gas can be organic vapors, example alcohol, and halogen gas, example Cl2, at a low pressure and sealed. The advantages of quenching gas is it gives off electron easily. There is a strong absorption of ultraviolet rays, we will discuss later. The molecule absorbs electron at higher orbit. T energize themselves into molecular fragments. See, among the organic vapors and halogen gas, which is actually the best? Organic vapors are much effective, but they do not recombine after dissociation. See, the life of the GM counter is limited if you use organic gases, whereas halogen gas scores over the organic vapors. So, halogen gas recombine after dissociation. The life of the GM counter is much more longer than that of organic vapors. So if you draw a curve between the applied voltage and the counting rate, then you will get a curve like that for GM counter. So this curve is for GM counter consists of knee portion, plateau region and spontaneous discharge region. So the GM counter is operated in this region, plateau region it is operated. What is called spontaneous discharge region? If the voltage is too high, spontaneous ionization takes place, referred as spontaneous discharge region. So what is operating voltage? The operating voltage of the plateau region is about 1/3 of the distance from the knee to the spontaneous discharge region. So what is the voltage here? And up to this point, then you take 1/3 of the value, and that will be the operating voltage for the plateau region. So this is the spontaneous discharge region at high voltage. So GM counter should not be operated in spontaneous discharge region mode. That means the voltage should not be applied in this region. It should be actually somewhere around here. Let us see what is primary avalanche and secondary avalanche. When radiation interacts in the gas medium, it produces a small number of electron or ion pair. These ion pairs are accelerated towards the respective electrode. That is, electron move towards anode and positive ion moves towards cathode. If the electric field is strong, the electron gains energy and collide with the gas medium and produce more ion pairs. That is, ionization of atom leads to production of electron. This results in ejection of more electron from the atom's gas in the chamber. This is what we call it primary avalanche of gas, or simply amplification. So initially we produces primary ionization, that is electron plus positive ions. These electron while moving, they produces additional ionization. So there is a additional electrons are produced. This we call it actually primary avalanche of gas. In addition, the electron can cause excitation through gas medium. The excited molecule returns to the ground state, that is within 10⁻⁹ seconds, with emission of light and ultraviolet. These ultraviolet ionize the gas volume by multiple reflections. Ultraviolet also interact with the cathode surface and emit a set of electrons by photoelectric absorption. That means when ultraviolet interact with the cathode surface, photoelectric absorption takes place and resulting production of electrons. This production of electron is called secondary avalanche in the gas. Let us see actually the gas medium. Suppose this is the primary electron tracks comes and the primary ionization takes place with the positive and negative ion. The electron moving towards the anode, it interacts with the gas molecules and does ionization produce the primary avalanche. And when it does ionization, excitation, it produces ultraviolet rays. That both primary and secondary avalanche takes place, or simply we call it electron avalanche. The avalanche gives a gas amplification of 10⁻⁻, which is independent of primary radiation. Both primary and secondary avalanche are referred as secondary ion cascade or avalanche of ionization, or simply electron avalanche. It becomes dominant and the main ionization event fades away. It determines the pulse size unchanged by the energy of the particles. Even single ionization event gives measurable ionization current or pulse. What happened after the electron avalanche? The electron and positive ions are not same. Electrons are light particles, it moves faster. Positive ions are heavy, they move slowly. Therefore, what will happen? The travel between the electron and the positive ions are totally different. So when electron goes finite time or particular time, the positive ions actually traveled only a small amount of time. Therefore, the positive ion forms a hose of positive ion which is formed around the anode. This terminates the avalanche process since positive ions reduce the effect of the electric field. What is pulse counting? Ionization current passing through the circuit register generate a voltage spike which is called pulse or signal. This pulse is amplified around 5 to 50 volts electronically before counting and transferred to the counter. The counter is connected to a loudspeaker for audible sound. There is some requirements for the detector. The two interactions must be separated with a finite amount of time, that is called dead time, we will be see later, to enable two distinct signals. This is a very important condition for GM detector. What is dead time? The interval between the two successive pulses is called dead time or pulse resolving time of the detector. If an interaction takes place within the dead time, it will not be recorded. Two pulses overlap, a disturbed signal may appear. GM dead times ranges from 50 microseconds to 200 microseconds, whereas the dead time of other detectors like ionization chamber is less than few microseconds, that is 1 microsecond or 2 microseconds like that. What are the features of the GM counter? GM counter is simple, rugged and relatively inexpensive. It generates same electrical pulse whatever the energy of the photon. It is capable of detecting alpha, beta and gamma radiation. It responds to individual photon, beta particle, single disintegration of atom. They are also useful to detect low-level radioactive contamination. Particle may be counted in terms of counts per minute, simply we call it CPM. Radioactivity is measured in microsievert per hour or milliroentgen per hour. It can be used as a survey meter or contamination monitor. GM survey meter is sensitive than that of ion chamber by a factor of 10. They are sensitive to diagnostic radiology beams, which has 10 power 7 photons per millimeter square. What are the limitations of the GM counter? GM counter cannot detect energy. Neutron uncharged particle cannot be detected. It has a low detection efficiency, less than 1% for X and gamma rays. It is less efficient due to long dead time. Quenching chemicals easily disintegrate, hence life of the GM counter is limited. What are the applications of the GM counter? It finds application radiation dosimetry, radiation protection, experimental physics, nuclear physics. It is useful to survey cancer patients with iodine-131 therapy in nuclear medicine. It is also useful to monitoring, workplace monitoring, clothing, shoes, contamination in cyclotron and PET-CT. Measurement of leakage and survey is possible in medical X-ray exposures. Useful to examine food and radioactive contamination. It finds application in uranium mines, rocks, minerals, soil test, depleted uranium, scrap metal and jewelry industry. So this is the type of GM counter used in universities and research institutions to carry out research as well as for practicals. I hope you enjoy the video. It find useful to you. Kindly subscribe and succeed. We will come back with the next topic in the next session. Thank you very much.